So hello and welcome dear students. So today we are going to start classification of quadrilateral, very interesting topic and very important topic for the all classes, right? So now if you just see quadrilateral, I will just start with the meaning of quadrilateral. What is the meaning of quadrilateral? Quadrilateral is what? It is four-sided polygon. We call it four-sided polygon. It means a polygon which is made up of four line segments. This is very clear, but there are infinite possibilities for a quadrilateral. But out of infinite quadrilaterals, we have taken some particular type of quadrilaterals which have some specific things, which have some specific shape, some specific property which we are using in daily life. So we will consider only those quadrilateral and we have given the names, right? So one by one we will try to understand, and there are so many 2 or 3 figures which are very common to you, which you know very well, which you have seen in the 5th class or 6th class, right? So we will start from the beginning. So first figure, if you see the first quadrilateral, which is four-sided figure, it is a square, right? So how can you identify that it is a square? So what is the reason? How can you say that like this particular quadrilateral will be a square? So what are those qualities or what are those conditions you see in that figure? So first of all, I will see square is in this form, right? So first property which square is having, first is all sides are equal. All sides are equal. And one more property which we have to check, because only by this particular condition we cannot say that it is a square. So what is the other condition which will make it a square? That condition is all the sides are equal and each angle is 90 degree. Because if each angle is not 90 degree, then you cannot say that it is a square. So we have to see both conditions together. We have to see that this particular figure is satisfying all sides are equal and each angle 90 degree. It means both conditions should satisfied by the figure. If it is, then we will say that it is a square. And what are the other things which we can see in the square? One thing is we can see that diagonals. If you see the diagonal part, these two things, diagonals are equal to each other, and bisect at 90 degree. It means ये वाला जो angle आएगा, this angle will be 90 degree. So this one is an additional condition. If you are not seeing these, this first condition here, and if you are seeing like this condition is given, so then also you can say that it will be a square, right? So diagonals should be equal and they should bisect each other at 90 degree. I want to tell you, suppose I am making a square here. Just try to understand. And this is suppose A, B, C and D. And I am saying this is the diagonal, first diagonal, and this is the second diagonal. If both diagonals are equal and they are bisecting means they are making half of each other. So we will say that yes, it will be a square. So out of these first condition or second condition, you have to check. If any one condition is given, then you will say that it is a square directly without any doubt. Now I am coming to the next part. Next is what? Next is rectangle. So rectangle is, what is the property of rectangle? Rectangle looks like this, right? It is looking like this. So in this particular figure you can see like adjacent sides are not equal. You can see here adjacent sides are equal. If it is A, so it will be AA. So but in this case, if it is A, so it will be something else. It means suppose we are saying that it is B, or we can say that if it is 30 centimeters, so it can be 20, or it can be something else. So it means these two adjacent sides cannot be equal. So in rectangle, opposite sides are equal, and but this condition is not actually for rectangle. We have to complete it. If each angle is 90 degree, now you can say that it is a square. So it means you have to check opposite sides are equal and each angle should be 90 degree. Only by one condition we cannot say that it is a rectangle. And what can be other? What can be other is all diagonals are equal. Diagonals are equal and bisect each other. Now student, you can see that I have stopped my statement here, but in the first one I was writing they are bisecting at 90 degree, but in rectangle case they will not bisect at 90 degree, but yes, they are equal and bisect. This is the last second condition. Suppose it is a rectangle, if it in this particular figure opposite sides are equal, it is not given. So how can you identify? So you will check diagonals are equal or not. If diagonals are equal, then you can say that yes, it is a rectangle, and they are bisecting also. They are bisecting also, right? So this was the condition for rectangle. Now I am coming to the, so this is the basic difference you should understand. Then we will correlate all the figures together. Parallelogram. What is the parallelogram? Parallelogram is, having some different condition. Parallelogram is saying like opposite sides. If opposite sides are equal or parallel. Anyone. If opposite sides are equal, then also you can say that it is a parallelogram. If opposite sides are parallel, then also you can say that it is a parallelogram, right? And there is no need to have any angle 90 degree. So it means one condition is less as compared to rectangle in this case. And other thing, what you can say that diagonals bisect each other. Diagonals bisect each other. Now again in this second condition we have reduced one particular part here. What? Diagonals are equal, but here there is no need that diagonals are equal. But one condition should be there, diagonals bisect each other. If diagonals bisect each other, then we can say that yes, it is a parallelogram. So it means to just justify that it is a parallelogram, it is very easy, because only we have to check opposite sides are equal or parallel, or we can check diagonals bisect each other or not. So how you will interpret it in the figure? Suppose it is a parallelogram. So in parallelogram you can check this particular side is equal or not, or if it is not here, so you will check diagonals bisect each other or not. If any one condition you can check, or you are taking, you are seeing, you are looking there, then you will say that it is a parallelogram clearly, right? Now I am coming to the next point, rhombus. Rhombus is saying all sides are equal. So if you see a square part, all sides are equal, but in a square we have to check angle also. But here there is no need for checking for 90 degree, right? And the second condition is all sides are equal and diagonals bisect each other at 90 degree. It means there is no need for equality for diagonals. But what is the difference between this one and this one? Here diagonals bisect each other, but here diagonals bisect each other at 90 degree, and in this case diagonals bisect each other at 90 degree, but they are equal also, right? So you should understand the specific difference. What is the difference? The difference between the square and rhombus is, in this diagonal wise diagonals should be equal, but here there is no need for equality in diagonals. All sides are equal, here all sides are equal, but there is no need to check the angle part. So you should understand what are those conditions between rhombus, what are the differences. You can understand between the rectangle and parallelogram, what are the requirement for checking, right? Now trapezium is very simple. Trapezium says only you have to check one pair of opposite sides are parallel. So this is the only one condition by which you can check it is a trapezium. If any one pair, suppose I am saying this one, if any one pair is parallel, means this line is parallel to this line, and it is not equal also. Only you have to check the parallel condition. If they are parallel, then you can say that it is a trapezium, right? Now after that we have one more figure, that is a kite. We will explain, but before this one we are correlating all these things together. Okay, what is the condition of parallelogram? One pair should be parallel. So in this particular case, these two lines are parallel or not? Yes. So it means it is actually satisfying the condition of parallelogram, sorry, trapezium. So can we say that square is a trapezium? Yes, because square is actually satisfying the property of trapezium completely. So it means square can be a trapezium, but all the trapezium cannot be a square, because it is satisfying the one condition which is required for trapezium. It is satisfying it. Okay, now some student can say that rectangle is also satisfying, parallelogram is also satisfying, and rhombus is also satisfying the property of trapezium, because each shape is containing opposite sides parallel, and here to all the opposite sides are parallel, both, but here only the requirement for one. So it means they all comes in the category of trapezium, right? And the second one, this is the one way, like we have correlated with the trapezium. Now if I correlate with the parallelogram and rectangle, for example, okay, rhombus, okay, we can do rhombus or parallelogram both together. If I say parallelogram, what is the condition? Opposite sides are equal and parallel. So in this case all sides are equal, so can we say that opposite side is also equal? Yes, and they are parallel also. So it means what? Square can be a parallelogram. Rectangle, opposite sides are parallel or equal? Both. Yes, we are not seeing 90 degree, but it is also not saying that we should check 90 degree, but it is given 90 degree, that is extra part, but actually it is completely satisfying the property of parallelogram. So we can say that yes, rectangle is also a type of parallelogram without any doubt, right? And other thing, it means rectangle, rhombus can be a square, can be a rhombus, but all the rhombus cannot be a square. Rectangle can be a parallelogram, but all the parallelogram cannot be a rectangle. So it means you should understand why I am saying this statement, why they are like square is a rhombus but rhombus cannot be a square, because all the rhombus cannot satisfying the property of a square, because square is saying ki I want 90 degree angle, but rhombus never have any type of condition, but square is satisfying the whole property of rhombus. So this is the very small differences, and we are categorize the classification of quadrilaterals accordingly, right? So please note down, because this is the basic difference and students gets confused here. Okay, now I am coming to the last one is the kite. Okay, kite is again very interesting shape. If you see the kite looks like this, right? I think by figure only you can understand the adjacent side are equal. If two adjacent side are equal, then we will say that it is a kite. Or there is one more condition, there are two diagonals, right? And both diagonals are meeting at 90 degree. Both diagonals are meeting at 90 degree. So we will say that two adjacent sides, one pair of adjacent sides are equal and diagonals are meeting at 90 degree, and now they are not bisecting, but one diagonal is bisecting by the other. This bigger one is not bisecting, but this smaller one is bisected by the bigger one, right? So we can say that this one, it means this particular part is 5 centimeter, so it is also 5 centimeter. So now I think kite square is satisfying the all properties of kite, right? But yes, rectangle is not satisfying, because I want adjacent sides equal, but rectangle says adjacent, no, not adjacent, opposite sides are equal. Rectangle, parallelogram, rhombus is also not satisfying, right? because we want diagonal should be at 90 degree bisecting. Oh sorry, rhombus is also satisfying. So it means we have to check whether which type of figures are satisfying the property of kite. So we can say that square can be a kite because square is satisfying the property of kite. So this was the classification, and please write all the properties in the same way so that you can understand the difference, because if you will write separately then you will not able to find the difference properly. So I think class, this was all about the classification. I hope you have understood, and you can do these type of sums related to quadrilateral. Till then, thank you so much for watching this video.